Unit 9, Lesson 3, we're going to start by graphing the provided function in number 1. First, I'm going to identify what is the period length. So I'm going to take pi, because for tangent and its reciprocal cotangent, I'm going to divide by the value in front of x. So pi divided by 2 is pi over 2. And then to figure out the scale factor, I'm going to take the length of this cycle and divide it into 4 equal steps. So when I divide this by 4, I could write divided by 4, but I know that's the same thing as multiplying by 1/4. I end up with 1 pi over 8, or pi over 8. Now I'm going to come back to this value in front. That is going to, because that value is between 0 and 1, it's going to squish the function down or make it a little bit flatter. We say that it's going to compress vertically. But first we need to come up to this picture looking at our unit circle. And when I decide the output values for a tangent, I'm looking at these key points here. And now, how do we figure out what the output of those values would be? So we're going to take sine and divide it by cosine. Recognize that sine is the second number. So let's start here. If I take 0 and I divide it by 1, 0 divided by 1 is an output of 1. Now, when I divide radical 2 over 2 divided by radical 2 over 2, they're the exact same numbers and they have the same sign. In that case, we always get an output value of 1. At pi over 2, I'm going to take the sine and divide it by the cosine. We can never have 0 on the bottom of a fraction, and that's why it's undefined. Undefined is going to cause us to have a vertical asymptote. Down here, I have the same values, but they have different signs, which results in a -1. And again, at 3 pi over 2, I have -1. That's the sine value divided by a cosine of 0. We can never have 0 on the bottom, and that makes it undefined. Okay, so I'm going to write down those values. I'm going to come back here. Keep in mind that those outputs were 0, 1, and undefined when I went up. So when I went up into this region, if I can take the highlighter, when I went up, I have 0, 1, and undefined, and then I had dropping down, I had -1 and undefined. -1 and undefined. So I need to take those tangent output values and I need to multiply them times 1/2. So 0, that's the output, times 1/2 is still 0. 1 times 1/2 is 1/2. -1 times 1/2 is -1/2. And we have a vertical asymptote, 2 steps to the right and 2 steps to the left. It's looking something like this. Approaches the vertical asymptote, never touching or crossing it. Now I'm going to continue that as I go to a cycle to the right and a cycle to the left. Okay, so I've done a cycle to the right, cycle to the left. Now let's figure out what is the length from here to here. Well, one cycle is pi over 2, and then I have half of a cycle of pi over 2. Let me have one full cycle, and then I have a half cycle, so that's 1.5 cycles. So 1.5 divided by 2. I'm going to grab a calculator. I want 1.5 cycles from the origin moving to the right. Okay, so 1.5 divided by 2, turning it back into a fraction, gives us 3/4. 1.5 divided by 2. So this is going to be 3/4 to the right, 3/4 pi to the right, and -3. Before I begin on number 2, I'm going to rewrite this as y equals -2 tangent of 1/2 x. When I identify the period length, I'm going to take pi and I'm going to divide it by 1/2. But when we divide, we really flip the second fraction, and I end up with a value of 2 pi. Now to get the scale factor, I'm going to divide this by 4, so 2 pi divided by 4 is going to reduce to 1/2 pi. Looking back to number 1, remember, that means that each step here along the horizontal axis is a distance of pi over 8, and the entire cycle is a distance of pi over 2, just to review from lesson 2. All right, let's get started. So it's going to go back to exactly what we did before. We have 0, 0, +1, undefined, 0, -1, and undefined, just like I had over here. But instead of multiplying by 1/2, the amplitude, we're going to multiply by -2. -2 times 0 is 0. 1, that's step 1. 1 times -2 is -2, and then it's undefined. Negative 1 times negative 2 is a positive 2, and my second step to the left is going to be undefined. So this is stretched vertically by a factor of 2. The negative sign has it reflect across the x-axis. I'm going to repeat the cycle to the left and to the right. All right, now the last thing we want to do is we do want to identify the x maximum and the x minimum. So this is 2 pi, and then we have a half. Well, half of 2 pi is 1 pi, so 1 pi and 2 pi would be 3 pi to the right and negative 3 pi to the left. Let's take a look right now at number 2, or I guess this should be number 3, and I'm going to rewrite it as y equals 3 tangent of pi over 2x. So to identify the period length, I'm going to take pi and I'm going to divide it, or in fact multiply it by the reciprocal of pi over 2, which is 2 over pi. And now when I take pi times 2 over pi, it's going to reduce to a value of simply 2. That's the length of one period. Like from here to here would be a length of 2 for this particular function. Divided by that by 4 gives us an x scale for every step of 1/2. All right, let's write this down. 0, 1, undefined. 0, negative 1, undefined. We have a value of 3 out front, so it's an amplitude of 3. 3 times 0 is 0. 1 times 3 is 3. Negative 1 times 3 is negative 3. So it's stretched by a factor of 3 vertically. I'm going to now do a cycle to the right and a cycle. Okay, there we have it. We have our function. Let's now identify the x minimum and the x maximum. So this is a length of 2, and half of 2 would be 1. So 1 plus 2 would be 3 to the right, and negative 3 to the left. Let's take a look at 4, 5, and let's take a look at number 4. Number 4 is the function y equals 3 times the secant of 1/3 x. So let's just first focus in on what is the parent function here, which is just y equals the secant of x. Now, secant is the reciprocal of cosine. So I want to identify, going around, what would be the cosines. Cosine is 1, 0, negative 1, 0, and then back to 1. So 1, starting here and going counterclockwise, 0, negative 1, 0, 1. All right, so there we go. So step 1, step 2, step 3, and step 4. All right, but next we need to take the reciprocal because it's secant. These are the cosine outputs. So how do we take the reciprocal? We're going to put 1 over that value. So 1 over this value, 1 over this value, 1 over this value, and so on. So my first step for the parent function would be 1. Now we can't have 0 in the bottom, so it's undefined. Then I have an answer of negative 1. It's undefined, and then back to 1. Now, how am I going to use that? Let me write that down. All right, so how are we going to use this? This starts here at the origin and then moves to the right. First, let me rewrite this as y equals 3 times the secant of 1/3 x. Now, secant is a reciprocal of cosine. So in order to figure out the period length, I'm going to take 2 pi and I would divide by 1/3, which is the same as multiplying by the reciprocal, or 3 over 1. Either way, I'm able to achieve a period length of 6 pi. I'm going to divide that by 4, 6 pi divided by 4, and reduce it to get 3 pi over 2. So I've taken care of the 1/3. Now I need to address the 3 out front, which is the amplitude of this. So here we go. At 0, I should have an output of 1, but now I have an output of 3. My next step is going to be undefined. Negative 1 times 3 is negative 3. Then it's undefined. 1 times 3 is 3. And it just keeps cycling through. So I'm back to this 1. This is back to this position. Then it's undefined. And I'm going to continue doing this to both the left and now, without looking back in what we've previously produced, I'm going to show us how can we actually draw a graph, because we can't just have dots. This is more than just dots. We need to draw a graph. So I'm going to look between, this was at 0 and this was at, if you want to think in terms of degrees, 90 degrees or pi over 2. I want to know what should be the output value to let me know, is this going down or is it going up? What's happening? So I'm going to look right now and choose a value between 0 and 90 degrees. Let me pull that up. Okay, so looking here between 0 and 90 degrees, let me switch the colors here. I want to choose one of these three really common points to take the reciprocal of. Now, the easiest one to take the reciprocal of is at 60 degrees, because if I take the reciprocal of the cosine, I get a 2 over 1. So in between here would be 2 over 1, or 2. And between these two, the easiest reciprocal to take would be negative 1 over 2, or negative 2. And under here, the easiest reciprocal of cosine would be down here, and that would be, again, a negative 2. And then we can go over here. Again, we're going to go the reciprocal of the cosine, because secant is the reciprocal of cosine. And this would be positive 2. So let me come up here and come back to my paper here. So in between these would be a positive 2, and a negative 2, and a negative 2, and a positive 2. How is that going to help me? Well, here would have been my 1, but again, I multiplied it by 3. Now, I would have gone up to 2, but 2 times 3 is 6. So at this point, I'm going to go up 3, 4, 5, 6, somewhere right up here. Okay, there's my undefined line. Now, in between this undefined line and negative 1, but it's down to negative 3 because negative 1 output times 3 is negative 3. In between that, I would have gone down 2. So normally I would have gone down 2, but negative 2 times 3 is negative 6. So way down here at negative 6. And between this point and the next vertical asymptote, again, I would have a negative 2 again, so way down here to negative 6. And you guys are catching on up here at 6. And we can see how I was able to produce this function. All right, so 1 period is 6 pi. So let's count here. Every 2 spaces here accounts for 6 pi. Every 2 spaces account, oh, sorry, take that back. 1 cycle here, let me go back here. 1 cycle here is a distance of 6 pi. So a cycle begins here and it ends here. I need to cut this off with, there we go. Cycle begins here and it ends there. That is 1 cycle. 4 steps, 1, 2, 3, 4. So I have 1 complete cycle and I have 2 more steps, which would be a half of a cycle. 1 full cycle plus half of a cycle, half of 6 is 3. That gives me 9 pi to the right and negative 9 pi to the left. Let's look now at number 5. Okay, taking a look at number 5, we have y equals negative 5 halves cosecant of 4x. So cosecant is going to be the reciprocal of sine. So let's come back here and let's identify where our signs. So 0, 1, 0, negative 1. Okay, so we have a 0, a 1, a 0, a negative 1, and then back to a 0. And remember, when we find the cosecant, we're taking the reciprocal of sine. That means I'm putting 1 over those values. 1 over the output of those sine values. So this is undefined, this is 1, this is undefined, this is negative 1, and this is undefined again. Now I need to find a value in this first quadrant where I can easily take the reciprocal of the sine to get an output for the cosecant. So let's look at those signs. The easiest one to do is 1 over 2. So the reciprocal of 1 over 2 is 2. Now between this output of 1 and undefined, again, I'm able to find a reciprocal of negative 1/2 would be, sorry, the reciprocal of, that's a positive, oh, I did the wrong one here. I meant to do this one right here because we are doing sines, not cosines. Reciprocal of positive 1 over 2 is 2 over 1. Down here, the reciprocal of negative 1/2 is negative 2. And over here, the reciprocal of, we're doing sine, which is right here, of negative 1/2 is negative 2. Let me write that down on our paper. Okay, so we're starting here at the origin where it's undefined. So it's undefined here at the origin. And then I'm going to go over 1 and up 1. Now it's a parent function. It's not this one, but in between here is 2, 2, negative 2, and negative 2. So it's going to be one step, another output, okay, now before I start graphing, let's come back here. Let's figure out what the period length is. So again, cosecant is reciprocal of sine. So I'm going to take 2 pi and divide it by 4, which reduces to 1 pi over 2, also written just as pi over 2. Then we're going to take and divide this by 4, which is multiplying by 1/4, which is multiplying by 1/4 in order to get the x scale. So dividing by 4. Let's bring this back down here. 1 pi divided by 2. 1i divided by 4, it's the same as multiplying by 1/4, so I get 1 pi over 8, or pi over 8. All right, let's go ahead and let's start graphing here. This is what I need to multiply, negative 2.5, negative 2.5. So I already have at my first, at the origins, undefined. Now my next step should be up 1, but 1 times negative 2.5 is going to be negative 2.5. And then I have undefined, and the next one should be at negative 1, but negative 1 times negative 2.5, well, two negatives make a positive, and I end up with a positive 2.5. Again, I should be, after this, it cycles back again, so it should be a positive 1, should be here. Positive 1 times negative 2.5 is negative 2.5. And I can do this over here too, but we can't just leave this with the dots. We need to actually be able to graph the function. So between undefined and 1, I should go up 2. Now what is 2 times negative 2.5? Because 5 divided by 2 is 2.5. So negative 2.5, let me clear this. Negative 5/2 is negative 2.5, and I want to take it times 2. And we get an output value of negative 5. So negative 5 is going to be here. 1, 2, 3, 4, 5. And also the same thing here, negative 5. Now in between here, I should be going down negative 2, but negative 2 times negative 2.5 is a positive 5. And we can see the remaining parts of this function. All right, so let's go back through it now, and we can see that we have a period length here, so it takes 4 of these to make one period, so I have a period and a half. So I want to take 1.5 times 1 pi over 2, because that's the length of one period. So 1.5 times 1 and divided by 2, turning it back into a fraction, is 3 pi over 4. So this is 3 pi over 4, and this is a negative 3 pi over 4. In our final problem, just as we did in problems 4, 5, and 6, I wrote down what is the output values for secant and what is the output values for cosecant. Now the output values for cotangent starting at the origin would be undefined. And then I'll take the amplitude times the output values to precisely see what this function looks like. But let's first start by finding the period length. So with cotangent and tangent, I'm going to take pi, and I'm going to divide it by whatever value is in front of the x, which is 2/3. Now when we divide by a fraction, we really multiply by the reciprocal. So as I take pi times this value, I'm able to get 3 pi divided by 2. Now to find the x scale, I take this value and I'm going to divide it by 4, which is multiplying by 1/4 to get 3 pi over 8. So I've taken care of this part. Now let's multiply the amplitude times the output of the cotangent. All right, here we go. So it's undefined. Now I would normally go over 1 because it's the first step, and up 1. 1 times negative 3 is negative 3. Would normally go in my second step over and stay at 0. 0 times negative 3, still 0. Over to my third step, 1, 2, 3, would normally go down 1. Negative 1 times negative 3 is positive 3, and then I'm back to being undefined. Okay, we'll continue this here, the same pattern. 1, 2, 3, 4. All right, there we go. Now I have 1.5, so 1.5 times the period length. So I'm going to take my period of 3 divided by 2, and I want to get that answer, take it times 1.5, then hit math fraction, enter to get 9 pi over 4. Attach the pi on afterwards and negative 9 pi over 4 to the left.